Hello everyone, my name is Oliver. Today we are going to learn about force. As we all know, the force is the most important concept in both physics and engineering. Let's just begin with a simple question, okay? In our daily life, why do objects keep moving while others stop? Yeah, that's great. That's the reason of force, right? And force is simply a push or a pull. And the force can change the motion of the object. And the force is invisible in our daily life, but we can actually see its effect. For example, when I push the chair just moves. And when I stop the chair, if I stop pushing, the chair just stops. Why? Because there's friction, and friction is one of the forces. So whenever you see the object changing its direction or speed, there must be a force acting on it. And then we can see force can be divided by two groups. First one is contact force, like friction, air resistance, or just a push with your hand. The second is non-contact forces, like gravity or magnetic force. Question time. Can you think of an example of in our daily life of a force? Now let's talk about the balanced force and unbalanced force. Let me give you an example here. If we give the object two forces in the opposite direction, like F1 equals to 5 newtons, and F2 equals to 5 newtons as well, we can call these forces is balanced forces. And if we give the object different forces in the different direction, like F1 equals to 5 newtons, and F2, we only give it 4 newtons. And we can call these forces are unbalanced forces. And when forces are balanced, the object stays still or keeps moving at the same speed. And when forces are unbalanced, the object will accelerate, slow down, or change direction. Now think about our tug of war game here. If both teams pull with the same strength, the ropes just stay in the middle. But if the one of the team is stronger, the rope will move in their directions, right? That's unbalanced force. And unbalanced force are what are in our daily life what creates motion and change. Okay, question time. If I push a wall with my hand here, does the wall move? No. Why not? Yeah, because this is the balanced force, right? Now let's talk about Newton's second law. The formula is F equals to m times a. And the force here is the force, m is mass, and a is acceleration. So from this formula, you can say if you apply more force, the object accelerates more. Or if the object has more mass, you need more force to move it. Is that clear? Yeah. And I can give you an example here. Here is a bicycle and a car here. That is why that it's easier to push a bicycle than to push a car, because a car has much larger mass. So even if you use the same force here, like 5 newtons here, 5 newtons here, the acceleration is very small. That's why engineers need powerful engines to move heavy vehicles. Without applying enough force, the car won't accelerate. Now think about your daily life. Can you give me one example of balanced force and one example of unbalanced force? Take a moment to imagine. Do you need help? Okay, I can give you one. Here is an elevator here. If the elevator is still, we can say it is balanced force because the upward force and the gravity is the same. They are equal, so they are balanced force. But if the elevator is stop moving, like the support force is very, very strong or very, very big here, and your gravity is very small, so it's unbalanced force. So you can feel yourself heavier or lighter. This is a perfect example from our daily life, right?
All right, class, here's a question for you. I'll give you a moment to read it carefully. Okay, Now let's think about it together. What are they actually asking us? Yes, the question is, what is the mass of the car? So what information do we already know? Take a second, maybe turn to the person next to you and discuss what numbers can we pull out of the question. Right, we know the force is 20 newtons, the time is 3 seconds, and the car's velocity changes from 0 to 2.3 meters per second. Now, before jumping straight to the formula, let me ask you a question. Can we plug these directly into F equals to ma? Not it, right? Because we don't know the acceleration. The first step is, let's calculate the acceleration. Remember, acceleration is change in velocity divided by time. So, who can tell me the change in velocity here? Yes, from 0 to 2.3. That's just 2.3 divided by 3 seconds equals to 0.77 meters per second squared. Now we can use Newton's second law, F equals to ma. We have already known that F equals to 20 newtons and A equals to 0.77. So how do we find the mass? Exactly, rearrange the formula. M equals to F divided by A. So plug in the number. M equals to 20 divided by 0.77 equals to 26 kilograms. Great. So the car's mass is about 26 kilograms, right? Let's pause for a moment. Why did we need to calculate acceleration first instead of directly solving? Yes, because force depends on both mass and acceleration. So we had to find acceleration before we could use the law. That's the key idea here.
Let's quickly review today's lesson. The first one is the force is a push or pull. Second, balanced forces mean no change in motion. Third, unbalanced forces cause motion change. And the last one, Newton's second law, is F equals to m times A. Next time, we will apply these ideas to engineering structures like bridges. Okay? Thanks for listening. Thank you.